Okay, we're taking a look at the 21.40 here. We've got one charge here. This charge here is free to move. And we've got another charge here that's not free to move. That one's actually glued down. Okay, and they're both being subjected to an electric field up here. Now, this guy is going to do something, but this guy is not. Okay, he's not going to get acted upon by the electric field. Okay, but there will be a force between them that we have to think about. Okay. So if we're looking at the force diagram on this guy here, okay, it would look like this. We've got, here's a dot. Okay, we have a tension force pulling to the right. It's going to have to pull to the right because the tension can't move to the left. Okay, we're going to have some kind of a force on it. The electric field, because the electric field is acting in the opposite, it tells us what is pointing to the right, and we have a negative particle, then the force from that is always going to go this way. It's always going to go to the left because of the force on an electron will always oppose the direction of the electric field. Remember, electric field tells you the direction of the force on a positive particle. And then we're going to have an electrostatic force between the two charges. Okay. In this case, it's going to be a charge. It's going to be an attractive force, so it's going to be like that. Between the charges. The difference between those is going to be the electric field because it's not going to move. So the tension is just going to be the force of the electric field on the negative charge minus the force between the charges. Now, the question I asked, again, why doesn't this one matter in terms of the force from the electric field on it? Well, they say something like it's glued down to the table. That charge is glued down. So that means that no matter what happens, it can be a pretty huge force to make any difference. And these are all going to be big forces. But glued down implies it's not going to matter. So to find the force of the electric field on the negative charge, and again, I'm going to take the sign out too, because again, I don't care what the sign is. I mean, I do care what the sign doesn't matter, but I've already accounted for it here. So I've got, I'm going to use QE. That's going to be the charge of it, 6.5 times 10 to the negative 6 coulombs. All times the electric field, which they tell us in the problem, is 1.85 times 10 to the 8th newtons per coulomb. I multiply those, I get an answer of 1,203 newtons. Again, my coulombs can divide right out. And then I'm going to solve for what the force is between the charges. I'm just going to use Coulomb's law to come up with that. So that's going to be K, 9 times 10 to the 9th newtons meter squared over Coulomb squared. It's going to be 6.5 times 10 to the negative 6. Remember, it's microcoulombs times 8.75. times 10 to the negative 6 coulombs, all divided by, they tell us that they're 2.5 centimeters apart. We have to convert that into meters, so it's 0.025 meters, quantity squared. Okay. When you solve for that whole thing, you get 819 newtons. All right, so we work both those things together, and we get, oops, I forgot to write coulombs over here, sorry. Okay, so we get 819 newtons, and we multiply all that out. Okay, So we put those numbers up here. 1,203 newtons minus 819 newtons, and we get 384 newtons for our answer. And again, it's a little less too. Okay. We didn't say what direction that was in. That is to the right. Okay. And we can see that from the picture too, from our force diagram. Our force diagram shows that to be true. Now we're going to do the whole thing again, but we're going to make them both negative. So this one is going to be negative 8.75, and this is going to be a negative charge. And that negative is going to still be glued down. We're going to make it just the same glued down as before. Now, that means our force diagram will look different. We'll still have tension to the right. Again, it's a rope. It's going to have tension to the right. Okay. And we're still going to have our force from the electric field is still going to point to the left because, again, the field still points to the right. It's still our loose charge, the negative 6.5 microcoulombs, is still a negative charge, so we're still going the opposite direction. But because we have a negative charge this time, it's going to be a repulsive force. So that force of the charge is going to go the opposite way this time. And this time, the tension is going to be the sum of those two. We're just going to put the two together, and the rope is going to counteract those to hold it still. We don't have to solve them again. We've already solved them. The numbers didn't change. We just changed the sign. So we're going to take those two numbers from last time and put them in there. So last time we had the electric force was 1203, and we had the force of the charges was 819, both in newtons. So let's add the two together. We get 22 newtons. Okay. And again, you can see from our force diagram that it's to the right, so it's going to point to the right also.